Another type of equivalence class partitioning can take place on the outputs rather than the inputs. So in this example for human eyes, we'll look at the expected outputs rather than the parameters being passed into the function, and design our test cases to make sure that we exercise the range of outputs that we expect to see. So what human eyes does is it takes a duration in milliseconds and turns it into a string. Right, and from this spec, we can see that if we're dealing with a number of milliseconds less than 1,000, we want to return milliseconds. But if we're going from 1,000 milliseconds to up to 1 minute, we return it in seconds. And above a minute to an hour, we return it in minutes and seconds. And above an hour, we add an hour parameter. Let's take a look at how this output specification can inform the kinds of inputs that we want to provide. Right, because providing our prior input, we're looking at -5, -1, 0, 1, and 5. Right? This is what we saw for number previously, is not a great set of inputs for this function. Instead, we want to choose something that actually tests these different output classes. So in this case, we're interested in 0, 1,000, 60,000, and 3.6 million. Right, so what we want to do is we want to make sure that we test from each of these domains rather than from these other ones from before, right? Because these will exercise all of the output classes for the human eyes function. Let's take a look at a concrete example for Mario in the output partitioning domain as well. So here we have the set velocity function that takes the Vx and Vy for a figure and returns whether or not that figure is moving right or left. Right, and this is relevant because we need to know if the sprite for the figure should be facing right or facing left based on the direction that the physics engine has them traveling. So on its surface, this looks just like isGreater from before, where we have two number inputs. Right, so let's draw this out in the table. So we have Vx and Vy. Right, and if we drew this out exhaustively, again, we'd have 1.28 times 10 to the 617 power. Right, there are a lot of options in this space. But in this case, from the specification, we can see that we only actually care about Vx, because whether or not Mario is moving up or down doesn't matter for the sprite. They're the same. There's just left or right. All we care about is left or right. So in this case, all we really care about is a subset of this table. Right, and the subset that we care about is right here. Right, so we only care about the first row. From the specification, we know that we only care about Vx, because this impacts left or right. And really, this is all that we care about when we're testing this thing, whether or not we have left or right. So for output partitioning, we're just interested in these two test cases. So really, all we care about is -1 and 1, right? To make sure that the right sprite is returned if you're moving left or you're moving right. And in this case, using output partitioning can cut this state space down from this huge number down to just two test cases quickly and effectively.